Good morning, everyone. Hello. We'll wait a couple seconds here while friends join us. Welcome, everyone, to today's bite-sized Buhl. My name is Carissa Sedor, and I have a friend joining me today. Neha Joshi is here with us today, and we are going to take you all on a trip to some of our gas giants. So, Neha, do you want to introduce yourself?
Yeah, I'm Neha. I go to school at CMU where I'm studying physics with a focus in astrophysics, and I've been volunteering at the planetarium for a number of years now.
Yeah, Neha's been one of our awesome volunteers and doing a lot of different fun interactions with the public. So if you come to the Science Center and you come to the planetarium, odds are you'll see Neha doing something really awesome. So we are going to take a look today at, oh, excuse me. We're going to take a look today at some of the gas giants that we can see. Now, this summer is going to be a really exciting time because we actually have two planets. You can probably already guess which ones they are in our evening sky. So we're going to start by taking a look at some of those planets and where to find them. So what we're going to do is we'll go and view our evening sky. And this is just about, let's see here. Yeah, so this is just about 11 o'clock. So they're rising pretty late in the night right now. But we are going to take a look in the southeast. That's where you want to start to look. So in the southeast, right, we have the sun rises in the east, so our stars and our planets also rise in the east. That's due to the Earth's rotation, right? That's the Earth spinning, not anything moving above us, but it's us actually moving below the sky. But rising in the southeast is where you will look for our two stars of the show. So what we're going to do is we're going to go forward in time just a little bit after sunset. So right now, if you want to get a good look at them, you'll have to wait until just about 12:30 in the morning or 1 o'clock in the morning, but they are rising a little earlier each night. So this is kind of a little preview of what to look for. Now, an easy way to look for them, well, they're going to be pretty bright in the night sky. They're going to look like two pretty bright stars. Jupiter is going to be the brighter of the two. It's going to be on the left, and Saturn is going to be on the right. And you'll see them pretty close to the horizon early on, and they will move their way across the southern part of the sky. Now, another easy way to locate them is by looking for three bright stars in the night sky that form a very familiar star shape. You'll be able to look for something called the summer triangle. And it's made of three stars from three different constellations, but they're three pretty bright stars. And once you find those three, you can look just below them, and that's where you'll see Jupiter and Saturn. So find the summer triangle, look down, and there you will see your two gas giants. So, and again, I have our time set to about 1 a.m., and that's where they will be. So, pretty easy to find them in the night sky, but we want to get a little bit of a closer view today. So we're going to take a quick journey to these planets. So let's get ready to lift off from Earth. Here we go. There we have our beautiful planet, our beautiful blue planet. We can see all those city lights on the surface at night. It's easy to see where people live across the globe. And we can see the daytime coming into view here. And we get that line between night and day, which makes up one of my favorite terms in all of astronomy. That's determinator. But it's a pretty lovely planet, I think. But we are not here to talk about the Earth today. We are going to visit two of our gas giants. So let's head out and away, and let's actually head to Jupiter first. So we'll make our way through the solar system as we head towards our first gas giant here. Now, Jupiter is the largest planet in our solar system. You could fit about 10 Earths side by side across Jupiter's equator, across that middle part. You could fit over 300 Earths inside of it. So it is quite massive. And it's a gas giant, which means Jupiter has no solid surface. It's basically one big atmosphere. You can see the complexity in Jupiter's clouds. And you can also get a look at Jupiter's kind of unique shape because it's not a perfect sphere. Jupiter, because partly due to it's made of gas, but also because it spins very quickly. It spins once every 10 hours. So one day on Jupiter is only about 10 hours long. Because it spins so fast and because it's made of gas, it actually bulges out at the middle and forms a shape called an oblate spheroid, which is very fun to say. I definitely recommend it. Now, because Jupiter is the largest planet in our solar system, it has a lot of gravity, which means it tends to grab lots of things. So it has a lot of moons. Actually, it has about 79 moons at current count. And the better technology gets, we keep finding more out there. So there's probably more. They're probably just really small. But Jupiter has a lot of moons. Now, it has some pretty famous moons as well. So we're going to visit some of those today. Now, you may have heard of the Galilean moons before. These are 4 moons that were discovered by, well, a guy named Galileo. He was actually the first person to look at the sky with a telescope. Now, he didn't invent the telescope, but he was the first person to use it for astronomical purposes that we know of, at least. And he looked at Jupiter and actually found what he thought were 4 bright stars that were going around Jupiter, and later figured out that they were moons in orbit around Jupiter. So the Galilean moons are Jupiter's 4 largest. So we're going to visit 2 of them today. So first, let's head to the big one. Let's head to Ganymede. Neha, you want to tell us a little bit about Ganymede today?
Yeah. So Ganymede, like Carissa said, is actually the largest moon in the solar system. So it's Jupiter's largest moon and the largest moon in the solar system, and it's the 9th largest object. So it's larger than Mercury, which I think is pretty interesting that it's a moon orbiting another planet, but it's still larger than one of our other major planets. And Ganymede has a subterranean ocean. So the top layer is ice, which is pretty thick. And underneath that, it's thought that there's a layer of possibly liquid water. And this ocean is larger than all of the oceans on Earth combined, which is really interesting considering how big this moon is. It's still smaller than Earth, but it still has more water than the Earth does. And Ganymede has 3 main layers. So it has an iron core, which is pretty similar to what the Earth has. The Earth also has an iron core. But in Ganymede, the layer on top of that is mainly rock, and the layer above the rock is mainly ice. And this ice layer is about 500 miles thick, so it's very deep. And there are these interesting bumps and formations on the surface of Ganymede. And like I said earlier, the top layer of Ganymede is made up of ice. So what are these bumps and formations? Well, scientists think that there's a lot of rock mixed into this top layer of ice, and some of these formations are due to the ice forming around these rock formations. Another interesting thing about Ganymede is that it does have an atmosphere with oxygen, but this atmosphere is much too thin to support life. So unfortunately, we may not find anything that breathes oxygen on Ganymede, but because there is an ocean, we might be able to find other types of life there. We don't know yet.
Pretty awesome. Ganymede is definitely cool, and it's also really cool to consider that it is larger than Mercury, right? It's larger than a planet. So it's not surprising to find the largest moon in the solar system around the largest planet in the solar system. So we're going to head to another Galilean moon, right? Ganymede is just one of the 4 Galilean moons. We'll take a look actually at where Ganymede lives around Jupiter here. We'll pull a little further away because we're going to take a look at our next one here. We're going to look at one that's a little bit closer. So we're going to look at the moon of Io. So Io is a lot closer to Jupiter. And what we'll see here is that that makes Io a very interesting place. So its proximity to Jupiter causes a lot of really interesting things to happen on this moon. And as we get closer, you'll see how interesting of a place it is. So this is the moon Io. I like to think of it as a pizza planet, although it's not really a planet, right? It is a moon. But you can see its surface is covered with all these different colors. So Io is actually the most volcanically active body in our solar system. It has over 400 active volcanoes. It has so much geologic activity due to how close it is to Jupiter. So Jupiter's immense gravity is constantly pulling on this moon. It pulls and it stretches the moon as the moon rotates. And this stretching can actually cause Io's surface to stretch up to 300 feet every day. So whichever side is facing closest to it can actually get pulled and stretched about 300 feet every day. So you can kind of imagine as it's spinning and it's constantly being stretched, it's constantly getting all these cracks and bubbles up from underneath the surface, which make it very, very volcanically active. And its colors are thanks to that geologic activity as well. It has lots of silicates, sulfur dioxide on its surface, and it gives that planet its pizza-like colorations. So, pretty awesome moon. Did I just call it a planet? It's a moon. Pretty awesome moon, though. Definitely very, very colorful. Those volcanoes can spew hundreds of miles up too over the surface as well before eventually falling back down. So that is our friend Io. Then we're going to head off to our next gas giant here. So we'll say goodbye to Jupiter. And again, Jupiter is going to be nice and easy to spot in our evening skies as summer goes along. But next we're going to head out to the planet Saturn. So Saturn is the next planet in order if we're going from closest to furthest from the sun. Saturn is just behind Jupiter by, a couple million miles. But we'll see our beautiful ringed giant here. Now, Saturn is not the only planet with rings, but it definitely has the most extensive ring system out of all the gas giants. All of our gas giants do have rings, but Saturn has the brightest and the most kind of complex. So here we can see Saturn, its beautiful rings. Those rings are on average about 175,000 miles from side to side, but also on average only about 30 feet thick. They're very, very thin rings. And those rings are made of particles of rock and ice and dust that are actually in orbit around Saturn. So from afar, it looks like they're solid, but when we get up close, we can actually see made of particles that are in orbit. And we're actually going to get up close today because I want to take a look at one of my favorite moons in the entire solar system. Now, Saturn has 82 known moons. It actually has more known moons currently than Jupiter, but it has lots of different types of moons as well, including some moons called shepherd moons. So we're going to visit one that we'll see is actually inside Saturn's rings. And it's a little moon named Pan. So there we can see Pan kind of towards that outer ring there. As we get closer, you notice the rings and that ring material. And we'll see Pan here. Now, Pan looks like kind of a walnut, or maybe a ravioli, or an empanada. called lots of different things. We can see it is not shaped like most moons that we're used to looking at. So Pan gets its shape from where it is, around Saturn. It's known as a shepherd moon, which means it actually shepherds that ring material and collects it. So as Pan orbits, it sweeps up extra ring material and kind of packs it on like a belt around its equator there. So we can actually see that ring material that has collected onto Pan over the many, many millennia that it's been orbiting. And it doesn't have quite enough gravity to pull itself into a perfect sphere, so that's why it keeps that weird little shape. It's only about 20 miles across, about 21 miles at its widest. So it's a pretty small moon, but still big enough to have this impact and create that gap in the rings around Saturn. And it has a pretty spectacular view too of the planet. You can see all that ring material there. Well, we'll head out and away from Pan because we're going to look at one more moon around Saturn. This is another one of my favorites. I mean, I don't know. How can you pick one favorite? You can't. They're just all so cool. So we'll say goodbye to Pan, and we're going to head over to a moon called Enceladus. So Neha, do you want to take us to Enceladus?
Yeah. All right. So as we come upon Enceladus, you'll notice it's a very white moon. It's the brightest and most reflective surface in the entire solar system. And that's because Enceladus is an icy moon, just like Ganymede. Icy surface also has a liquid interior, so liquid oceans underneath, and some of the oceans actually get sprayed out into space. So you see these are called, well, these are what scientists call tiger stripes on Enceladus, and these warm fractures are where Enceladus sprays out some of the ocean and gases, water particles into space. And some of these particles actually end up in Saturn's rings through Saturn's rings. Now, that's only a fraction of what happens to these plumes. Most of what comes out of Enceladus in plumes actually falls back onto the surface, but it's so cold this far from the sun that some of these particles fall down like snow. So you can think of it as Enceladus is one of the moons where we can see snow. And Enceladus is also a pretty small moon. It's only about the width of Arizona. So I think it's pretty remarkable that it controls Saturn's rings, even though it's such a small moon.
It's really cool to see too, especially looking between Pan and Enceladus, the different ways that Saturn's moons can affect its rings. Here we see one moon that's actually scooping up some of that ring material, and we see another moon that's actually adding to it. So we'll get one more view of Saturn from out here. I love seeing Saturn from behind. We get this kind of in shadow view. It's a pretty beautiful planet. There's no doubt about that. And you can definitely see Saturn's rings if you have a telescope at home. Definitely try taking a look at Saturn this summer because you'll be able to see those rings. You can see them as Galileo saw them. He thought it was a planet with ears. But of course, we know that Saturn's rings are not ears. But that is just a quick look at what we're going to be able to look forward to this summer. So definitely go outside, take a look up. If you want to wait up late at night right now, you can and see these two planets for yourself. But otherwise, they'll be visible all summer long, well into the fall and even the winter. So definitely keep your eyes up for Jupiter and Saturn that are going to be stealing the show this summer. But for now, I think that's the end of our bite-sized Buhl today. So definitely come by and see us in the planetarium sometime. We are open, and we are running programming all summer. We'll definitely be showing Jupiter and Saturn off in there as well. So stop by, come see me, and come see Neha. Neha, thank you so much for joining us today.
Thank you for having me. I had fun.
That was a great time. So thank you, everyone. We'll see you soon at the Science Center. Have a great day.